What's up, everyone? Today we're going to talk about arithmetic sequences and series. All right, so first up, some vocabulary. A sequence of numbers is a list of terms arranged in an order that obeys a certain rule. It's very general. It can be finite, meaning it stops, or infinite, meaning it goes on forever and ever. Each number in a sequence is called a term, and the nth term of a sequence can be represented by a sub n, which is more of what we used in Algebra 2, or u sub n, which is what you'll see more in IB. But either way, n is a positive integer, and we say that because n determines or tells you the place in the sequence. A sequence is called arithmetic if you add the same amount each time to get to the next term. That amount that you add is called d, or the common difference, and it can be either positive or negative. You'll see both. And finally, the sum of terms of an arithmetic sequence is called an arithmetic series. The formulas we're going to use, which are given to you in the formula booklet, you do not have to worry about memorizing them. They're screenshotted right out of the formula booklet, so they don't tell you what each of these variables mean. You have to know that part. So that's what we're going to go through right now. U sub n, which you see a couple different times. U sub n is, just like we just saw, the nth term in the series or the sequence. U sub n, which again you see several times, U sub n is your first term. So that 1 replace the n, which tells me it is number 1 in the sequence or number 1 in the series. So it's the first term. D, just like we saw on the previous slide, is our common difference. N is the place in the sequence. And remember that n has to be a positive whole number because you're counting the placement in the sequence. Finally, S sub n is the sum of the first n terms. All right, so let's move on to example number 1. We're given the sequence and we're first asked to just show that it is arithmetic. So there's lots of different ways you can show that it's arithmetic. What I'm going to do is just kind of go consecutively. And what I mean by that is if I go with, or if I start with term number 2, which is 83, and subtract the first term, which is 87, I'm showing that I get negative 4. If I do the same thing, term number 3, minus term number 2, I get negative 4. One more time, just based on how many terms they gave me, if I do term number 4 minus term number 3, I'm showing once again that I get negative 4. So this is showing my common difference is 4. Part B, we're asked to find the formula for the general term. So I'm going to take the formula that we just saw on the previous page and just rewrite it first. And now I'm just going to start subbing things in. Remember, this is a formula, so just like an equation, you are going to have variables that you don't have anything to sub in yet. Usually when they ask you for a formula for the general term, your u sub n and your n will stay in the formula because that's going to change based on which term you're looking for. But I do have my first term, because I can see it right there, it's 87, so I'm going to sub that in. And I also have my common difference. I just found it in part A, which was negative 4. Okay. So just like other problems, even though it doesn't specifically say to simplify, it's always best practice to simplify. So in that case, or in this case, what I'm going to do first is distribute that negative 4. And then I'll go ahead and combine like terms with my 87 and my 4. And that is my formula for my general term. You could have switched 91 and negative 4n. Either way, it doesn't matter as long as you have both pieces. We're not going to be picky about what order they go in. Part C, determining whether or not negative 143 is a term of the sequence. So negative 143, they're saying if you continue the sequence out, will negative 143 be part of it? And I'm explicitly saying that because they're telling you negative 143 is u sub n, because that would be the actual term you would see in the sequence. What we're going to be looking for is n. Where in the sequence would that happen? We're determining that because if I get a negative number for n, or if I get a decimal or a fraction, that means it's not a term in the sequence. Remember, n has to be positive whole numbers. So that's what we're looking for. I'm going to sub in negative 143 for u sub n, and then I'm going to solve for n. Right, so I solved for n, and I got n to be 58.5. So because it's 0.5, it's not a whole number anymore. So I would have to say, no, it is not a term in the sequence. So think back to the question they asked you, or reread the question they asked you. You were determining whether or not it was a term of the sequence. So that's why it's a yes or no question. N equals 58.5 is not my answer. No is my answer because of that 58.5. Finally, part D, we're finding the first term of the sequence that is less than 34. All right, so same idea as C, that 34 is my u sub n. And I'm looking for n, which would get me possibly the first term or the first place in the sequence where that term would be less than 34. So I'm going to set it up exactly like I did in part C. And you could use inequality here instead of the equal sign. In my head, it's just easier to use the equal sign. That way you don't have to worry about, well, which way does the inequality go? And we'll talk about determining the less than part once we find n. All right, so I've solved for n, and I got that n is 14.25. So what that tells me is similar to part C, that 34 itself is not in the sequence, but that's not what they asked. They asked for the first term of the sequence that is less than 34. So this tells me that 34 would be between the 14th and the 15th term. They want the first term that is less than 54. So remembering that D, we were subtracting 4 every time. So we were getting smaller and smaller terms. Even though rounding rules would tell me if I wanted to round this to a whole number, rounding rules would tell me to round down to 14. But that would then be before I actually hit a term of 50 or of 34. So in that case, or because of that, I actually need to round up to n equaling 15 so that I can actually surpass 34, which was the goal. Now, they didn't ask me for the placement in the sequence. They asked me for the actual term. So final step is just to figure out, well, what is the 15th term? And that's just as easy, even though I'm running out of room, that's as easy as subbing in 15 for n and working it out. I got the 15th term is 31, and that is my answer. Example 2, we're first asked to find the sum of the arithmetic series that's given to us. So notice that they don't explicitly say a lot, but it still gives us quite a lot of information. I know my first term. I can easily figure out what my common difference is. So negative 10 to negative 6, or negative 6 to negative 2. I can see that I'm adding 4 every time. If you're ever not sure, similar to what we did in example 1, take the second term minus the first term, always subtracting, and that'll give you your common difference. So in this case, D equals 4. We also know what u sub n is. We don't know where in the sequence 90 is, but we know it is the last term of the sequence. So because of that, we need to figure out what n is. So instead of jumping straight to the sum, what we're going to do first is find n by using the general term formula. And we're using this formula because we have everything except n. That's the only thing in this formula that we don't have. So I'm going to sub in what I have. All right, and then solving this, it's up to you how many steps or which steps you take first, but your goal right now is just to solve for n. All right, so when I solved, I got n equals 26. And you can see my steps here. I didn't show all my work, but I showed my steps, what I got. Finally, part 2 is when we're actually finding the sum. And we had to go back and find n because if you look back at the formulas for either formula of the sum, you have to have n. So that's why we had to do that. It does not matter which formula you use in this case. It's really just your preference. For me, one of the formulas has u sub 1 and u sub n, and you really only want to use that if you have the last term like we have in this example. If we didn't have 90 and it instead just said find the sum of the first 5 terms, then the other formula might be better. It really doesn't matter. It just depends on, how much work do you want to do, or do you always want to use one formula over the other? It just depends. It's kind of like solving simultaneous equations, that sometimes one way is easier than others, but it's whatever you're comfortable with. So I'm going to write out the formula that I'm going to use, and subbing in what I know my n is 26 because I just found it. So 26 over 2 times my first term of negative 10 plus my last term of this sequence, or the 26th term, which is 90. And then again, simplifying or evaluating either in your head or with a calculator, we get 1040. Part B, finding the least number of terms that must be added to this series to obtain a sum greater than 100, greater than 100. So very similar to part C of example 1, that they're now giving us a sum and asked to find how many terms of the sequence would it take to get to that sum. So this value that they're giving us is the S sub n, and we're looking for what is n. What I also don't know is the last term of the sequence. I know the sum of all of those terms, but I don't know what this term is, or the last term like we did in part A. So because of that, I'm not going to use this formula because I don't have all the information. The question they're asking me for is what's n, and to use it in this formula, I would need this value as well. So I'm going to use the other formula. All right, so this is our other formula, and I'm just going to start subbing in what I already know. All right, so now that I have everything plugged in, I'll go ahead and simplify this right-hand side a little bit. All right, so simplifying it isn't required. It really just makes it a little bit more easier to manage. You could even simplify this further by distributing the n over 2 so that you have 100 equaling 2n squared minus 12n. Again, like you could have even just gone straight from this step when we just plugged everything in. But solving this for n, you have lots of different options. As you can see now that we've simplified that right-hand side completely, we're setting up a quadratic. So you could bring everything over to one side, try to factor and solve, use quadratic formula and solve. What might be easier, especially if, let's say, you don't want to do all of this simplifying work, you just want to work from this second step that I have here, what you can do is use your calculator, either Desmos or the TI, and set left side in as one y value, or a y1 in the TI, and set the right-hand side in as y2, and then look for their intersection point, remembering that we're looking for a positive value. So no matter which way you choose to solve, you're looking for the positive n value. I'm going to show you this in Desmos first. So switching over to Desmos, remembering in Desmos, you have to state for that left-hand side for 100, you have to state what equals 100. In this case, we're looking for y equals 100. And y equals the right-hand side. I changed the n's to x's, again, just so that Desmos can graph them. So this is what I see from my kind of home Desmos screen. Obviously, there's nothing to see here, right? I can't really see much, but remembering, again, that y value is 100. So it's all the way up there. So I'm going to keep zooming out until I can see that y value. Once you find it, you can go ahead and zoom in, but you don't have to. All we're looking for is the positive, so the right-hand side, the positive intersection. So going back to simultaneous equations, trying to find the intersection point between the 100 and the 2x squared minus 12x. If you click anywhere on one of the graphs or either of the graphs, those gray dots should show up, and I just clicked on the rightmost one, or the one on the right, which x value wise, I'm looking at 10.681. So that's the exact point where my sum would be 100. Okay, again, though, remembering n has to be a whole number. We already have a positive, that's great, but we need it to be a whole number. So we were trying to find the least number of terms that must be added to obtain a sum greater than 100. So just like we talked about in example 1, if I were to round down to 10, my sum hasn't reached 100 yet. But if I round it up to 11, my sum will have surpassed 100. And that's the value that I wanted. So I'm going to say n equals 11. They wanted the least number of terms, so you leaving it as n is perfect. To do this in your TI calculator instead of Desmos, in y equals, I already put in my left-hand side into y1 and my right-hand side into y2. Same kind of deal as Desmos. If you just hit graph, you're not going to see a ton. So you can either zoom and zoom out. And you'll just hit enter as many times as you actually can see that intersection point and then find the intersection point. What you can also do, what might be easier on the TI instead of trying to find the intersection point, is after you put them into y equals, go to the table and you'll look for the first positive value. I'm looking in this second y equals since that was the parabola. You're going to look for that first value that surpasses 100. That way it's already a positive whole number, and you don't have to try to find the intersection point. Final piece is just talking about summation notation. So you've seen this Greek letter sigma before, and it just means sum. You're adding up however many terms or what terms you're looking at. In terms of what it's going to look like to you, instead of using the S sub n format, you'll see this kind of format. At the bottom, you'll have the term number where you're starting, and at the top, you'll have the term number where you're ending, or where you're finishing. So it could be from 1 to 5, could be from 2 to 17. It'll change up, so you got to make sure you're looking at those small numbers. This, right next to it, that'll be your general term equation. Everything to the right of that equal sign, you wouldn't be given that. It's just showing you that this would be, the first term plus the second term plus the third term plus however many until you get to the last term. But let's put this into action with our final example. Example number 3, we have this expression, and we're asked first to just write it as a sum of terms. So what that means is we are not evaluating the actual sum. They just want it written out. What does that look like? So I see that I'm starting with term number 1, where I equals 1. So my very first term would be 2 times 1 plus 3. I'm going to put it in brackets just so that I remember myself that that was my first term, term number 1. And I have to go all the way up to term number 4. So I'm going to repeat this same expression, but changing that number in parentheses every time to the following terms. So I'm going to have 1, 2, 3, and 4. All right, so again, I took that same expression and just rewrote it 3 more times, changing the number in parentheses until I reached that number at the top. Part B, now we're asked to actually calculate it. So how you calculate it is up to you. If you want to work on your mental math and do each term separately and then add them all up, great. If you want to type them all into your calculator at the same time, that's also great. And I got 32. You can also do this in your TI calculator. It won't show you each individual term, but you can just do the entire summation in your calculator. To do the summation in your TI calculator, I'm going to go to Math, down to the bottom where it says summation, and you'll enter in almost exactly what it looks like on paper. Instead of I's, I'll use X's, just because we know our calculator likes it better. I'll still keep the 1. I'll hit the up arrow to get to the top to enter in my 4. And then I'll hit the right arrow in order to enter in the equation. Again, changing that I to an X. And then I just hit enter, and it evaluates the sum for me. So for more practice problems, we have a sum on this page and more here. And if you have any questions, feel free to reach out and just let me know.